You've got your Kincony board running OpenPLC, but there's a problem. The inputs are not working yet because they are behind a PCF8574 expander. OpenPLC is blind to them until now. Today, I am showing you the C++ fix to unlock all 8 inputs, in addition to the 8 outputs from the last video, and build your first real industrial logic. Now, let us create another function block for the inputs. Name it A8 inputs, and use the C language. Add int0 to int7 Boolean output variables to the variable table as the function block outputs. Then go to the GitHub link in the description and copy this code to replace the existing one. The code is commented just like the output code, so you can understand what is happening. To prove this actually works, we are going to map these variables and see them trigger in real time. Open the main OpenPLC program. Add a new room and drag the inputs custom block from the user-defined POUs in the Library Explorer. Add variables val0 to val7 to the outputs of the block. Add another room. Drag the output custom block onto it. Assign the same val0 to val7 variables to the inputs of the block. This will allow us to perform functionality checks on the board's inputs. The OpenPLC editor is great for logic, but since we are using a custom C++ block, we need to make sure the ESP32 actually knows how to talk to that PCF8574 chip. That is why we must add the library to the Arduino IDE first. Ensure that the Arduino IDE is already installed on your computer. Go to the Library Manager. Search for and install the PCF8574 library. Then go to Device Configuration in the OpenPLC editor and ensure the ESP32 ROM is selected and the correct COM port is chosen. Compile and upload to the board. I have connected one end of a wire to the board's input common terminal for testing. When the other end of the wire contacts each input, the corresponding output relays energizes as well as their LEDs. Now let's return to the OpenPLC editor and add a new rung between the input and output block rungs. Drag 2 contacts and a coil onto the rung, then negate the second contact. Add a start variable to the first contact, a stop variable to the second contact, and an indicator variable to the coil. Place a third contact below the first contact and assign the indicator variable to it. This, of course, is the retaining contact logic. Assign the start and stop variables to int0 and int1 of the input function block, and the indicator variable to out0 of the output function block. Then compile and upload to the ESP32 board. Now connect 2 push-button switches to int1 and int2 and to the board's common contacts. Also connect the indicator to relay 1 NO and common terminals from the 12V DC power supply. Pressing the start button turns on the indicator. Pressing the stop button turns it off. If this was helpful, please like the video and subscribe to stay tuned for the next part, where we explore analog inputs. Thanks for watching, and I'll see you in the next one.